Okay, yeah, Amit. Now I can see your background. So use that image. Not this one.
I tried the other image, sir. It looks mirrored to me. Just tell me if it looks
But
normal to
for
you.
you, it's fine. Yeah. For us, it is. It looks
Okay,
perfect
okay,
because
okay, great.
yeah. Yeah, yeah. This is perfect.
Yeah, great.
So even though it looks mirrored to you, so now, uh, okay. What is that? So you did you check the link of the intro?
Just a second, sir. I I read the press thing, not fully.
So, uh, give me a moment. I'll just coming back. Yes, yes, Amit. Tell me.
Yes, sir. So I read the introduction part.
Okay. So did you get an idea about the speaker?
Yes, sir, sure.
Okay, okay. So, uh, uh, okay, we can discuss just before the join. We can discuss something more. Okay,
Mhm.
about the flow. So there will be an introduction by uh, Chintamani. So I will introduce everyone right now. Okay, introduce everyone to you. So then, what moment you will come in? I will be just changing my internet connection. So it's possible that I might get disconnected for a minute or so. Okay, so just in case.
I think you got disconnected.
Probably. No, he's still the host. So, पता नहीं क्या हुआ.
Is the link private right now? Live on YouTube or it's public?
It's going live on YouTube.
Okay. Okay, so if it is live on YouTube, I'll start sharing the NASA live.
लाइव का पब्लिक में है ना?
Making a mistake. It's
Can
hard
you
no
hear?
matter what. Trying to do it during the middle of the pandemic, it's a lot harder. And liftoff.
Can
As
you
the
hear?
countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the red planet.
Certainly never done something like this before. Try to lead a team that's flying a spacecraft on the way to Mars while getting ready for landing, while doing it all from home.
There's no doubt that working in isolation, not virtual isolation, but in physical isolation from everyone else, is a challenge.
We had to rethink and redesign what it meant to operate a spacecraft in flight when we couldn't all be in the same room. human mission control, seeing the data come down from Perseverance.
It was a major change going to that, looking at everyone on a screen instead of in person.
Can you all
Because
hear?
of the pandemic, you can't, just pop over your cubicle wall and talk to the person next to you.
It's definitely been a challenge to figure out how to communicate and get everything done remotely. But we've managed to make it work.
We are explorers. Our job is to go into the unknown. And this is just another example of the unknown.
We're really doing something that's transformative and trying to understand whether or not life evolved.
Hari, can you check if there are any viewers on YouTube?
We're all connected.
ऐसे लग रहा है मुझे.
Private है
Mission
ना?
in this wonderful team that we have.
I'm on it.
Part of, so that keeps at least me going.
Pretty much everybody that I've talked to that's associated with the mission has said the same thing, which is you could not have come up with a better name than Perseverance.
It's an amazing serendipity that we get to persevere through working on Perseverance.
No, we can't hear.
Okay, Chintamani,
Yes, Vaibhav.
Well,
I can share now.
Okay.
I was just changing my connection. Sorry about it. I'll just
extremely capable.
Vaibhav, let's go live now.
yeah, I'll do it. Just give me a moment. I'll just sharing the screen, man,
Number
and then we'll go live.
to provide feed forward information to the next set of robotics for even human exploration of Mars.
Vaibhav, keep
I think
checking
there's a
in
lot
waiting
for
room
us to
also.
do. We look
Yeah,
a
yeah.
lot
or even human exploration of
carrying
Mars.
50%.
So there's a lot for us to do.
payload
We look a lot like Curiosity, but
Mars.
in fact we're carrying 50% more
It's been a big
payload down to the surface of Mars, and so it's been a big challenge. And it was particularly challenging to make it happen. The team was tenacious, and we managed to get it launched and fly it to Mars. Thanks to a lot of help.
And Matt, just how large is the team that worked on Perseverance?
It's a big team. A couple thousand people here just at JPL, in fact, have worked on the mission. And then almost every other NASA center has contributed in some significant and critical way as well. We have over 1,000 industry partners that have provided hardware into this mission from 44 different states, 60 different cities, and of course we have international contributions from Europe and many other international providers as well. So it's a big team. It's taken a lot of people to get us to where we're at.
That is a big team. This is the most difficult landing site ever attempted. Now, why do you think Perseverance is ready to land in Jezero Crater now?
Jezero is tough. I mean, it's scientifically fascinating because it's got a lot of things like craters and rock fields and cliffs and sand dunes and that sort of thing, which are great for the science community. That's exactly the type of features they're looking for to learn more about Mars. But they're all landing hazards for us, and so we've had to add new technology to relevant navigation, which is the ability essentially to divert away from hazards. But we have taken this system through the same types of paces that we have in previous missions. We've used the same techniques, the same best practices for engineering verification, and in many cases we've used the same people. This, in fact, is my fifth Mars rover mission, and I'm not alone. There's other people on the project in the same situation. So, the team has given it everything they've gotten to put it all out there and to make this successful, and I think we're ready.
Thanks, Matt, and good luck on your fifth mission.
Thank you very much.
Well, Jezero Crater
Yes.
is a location on Mars that has intrigued scientists for years. Let's head over to Marina to learn more about the science goals of the mission.
Hari, can you just check?
That's right, Raquel. Here to explain
Yes.
why we want to go there is Deputy Project Scientist Katie Stack Morgan. Welcome, Katie.
Thanks, Marina. Glad to be here.
Now, Perseverance is landing on Mars at the Jezero crater. Why is it that you and the team chose this particular area?
Vaibhav, can you hear me?
Yes, so scientists believe the Jezero crater is one of the best places on Mars and possibly the entire solar system to look for signs of ancient life. Jezero contained an ancient lake and has within it one of the best preserved ancient delta deposits in the...
Yes, Chintamani.
Yes, can you hear
We
me?
are live now.
Great.
Yes.
I can see. On
So here I have an option to mute the YouTube so that we can talk.
Correct.
So I will be muting the sound of the video stream, which is coming directly from the NASA live feed. And we can also turn on the video wherever there is a scope.
Okay. So are we
what were you telling?
on YouTube? Hari, can you check?
Yeah, I'll do that.
Down, I think the most rewarding discovery I think we can make with
also
Perseverance would be finding a truly compelling...
I also checked that the audio and video is coming on the YouTube.
time when life first arose in the solar system. And we have the opportunity with Perseverance to study the evolution of the planet from a once habitable world likely capable of supporting ancient life to the cold, barren planet we know Mars is today.
Yeah, it's perfect.
And why do you think, Katie, it's so important to find out if there really is or was ancient life on Mars?
Well, the question of whether there's life beyond Earth is one of the most fundamental and essential questions we can ask. And our ability to ask this question and develop the scientific investigations and technology to answer it is one of the things that make us as a species so unique. And based on everything we know about Mars in the past, it absolutely should have been capable of supporting ancient life. So we can find out an answer to the question, where there were habitable environments, was there life? And studying the possible emergence of life on ancient Mars can also help us better understand the conditions that led to life on our own planet.
Can you unmute yourself, Chintamani? Yes.
No, I think I'll message Jane Blank now that she can join.
Hi, I am Laura. And my question is, why was Mars able to sustain lakes and rivers ages ago, but cannot now? Isn't it cold enough to make water? And isn't it always? Thank you.
Yeah, that is a great question. And one of the things that protects our atmosphere and allows liquid water to be stable on our own planet is the fact that we have a shield protecting that atmosphere.
स्क्रीन में डिवाइड नहीं कर सकते कि एक में हाफ स्क्रीन यू कीप हाफ से पार्टिसिपेंट दिखेंगे ऐसा कर सकते हैं.
So there are participants you can see on the YouTube. You can just go and check.
Okay, YouTube. एक मिनिट म्हणजे एक पॅनल सारखं डिस्कशन वाटलं पाहिजे.
No, it is there. So there are, you can see on one side there are all people who have a video on. It is there. So there are, you can see on one side there are all people who have a video.
नाही दिसत आहे ना वैभव कसं.
When you are
दिख नहीं रहा है वैसे. तू चेक कर जरा YouTube चं. Anybody else can check and confirm.
Yes, sir. So there are, you can see on one side there are all
Vaibhav, maybe you can slightly cut the screen, slightly reduce it. Don't make it completely full screen. Okay, you can manually adjust the.
तर
Ankush, there is some echo coming.
हा आता नाही येत असेल ना. अरे मी काय सांगतोय चिंता, YouTube वर असं दिसत नाही, पॅनल सारखं दिसत नाहीये, ओनली व्हिडिओ दिसतोय.
Vaibhav, do one thing. Don't completely max.
सर्व 3-4 जण, ऍटलीस्ट 3-4 पीपल शुड बी देयर ना, जो पैनलिस्ट आहेत ते दिसले पाहिजे. हाँ अभी शायद ठीक है क्या? हाँ अभी ठीक है, अभी दिख रहा है. चाहे तो आइकन साइज बड़ा कर दो.
I think
Vaibhav, can you increase icon size maybe काहीतरी?
Are you able to see now, Ankush?
You guys have gone live, I think.
Yeah.
Okay.
You have shared with Dr. Jonathan Clark, right? All the details. You are not audible, Siddharth.
Yeah, I've shared it with him. The only thing is there's a Mars Society Australia watch party also going on.
Okay.
So your timing is such that there are a lot of events. But it's okay. I'll keep inviting people and asking them to.
हाँ नहीं अभी बोल तो रहे हैं. Screen.
Vaibhav, how many are there in the waiting room?
Sharing का problem है, black आ रहा है.
Around 8 people are there in the waiting room.
Okay. I think Vaibhav, Jen Blank is already there. I'll tell her to join.
Okay.
Could. Amongst the rocks and the craters and the cliffs, these things are hazardous to the rover, but these are the things that are interesting to the scientists.
Once Perseverance has figured out where she is, we jettison the back shell and parachute and light up our rockets. Those rockets help us steer to a safe landing spot that's nearby.
That descent stage takes us all the way down to about 20 meters off the ground.
That's when we start the sky maneuver. And once the rover has hit the ground, the descent stage will cut loose from the rover and fly away to a safe distance. And surviving that 7 minutes is really just the beginning for Perseverance. Its job, right, being the first leg of sample return, to go look for those signs of past life on Mars. All that can't start until we get Perseverance safely to the ground. And then that's when the real mission begins.
With us now is Al Chen. He is Perseverance's entry, descent, and landing lead. Al, you were part of the Curiosity rover landing. Does it get any easier the second time around?
It absolutely does not, especially when considering we're trying to land the biggest, heaviest, and most complex rover we've ever built at the most dangerous landing site we've ever attempted. Jezero may look great and promising from a science perspective, but it's absolutely treacherous for landing. There's a cliff wall that's about 200 feet tall that runs right through the middle of the landing site. There are craters full of sand that even if we landed them, we would not be able to drive out of. And there are rocks to the east and actually all over the place, rock fields. That would be a bad day for us if we were to land on them.
Now, Al, what new technology makes this type of dangerous landing possible?
Perseverance is carrying two new technologies that are really kind of under the hood smarts that are allowing us to land at this treacherous landing site. The first is range trigger. That's the ability, we've given Perseverance the ability to decide for herself, based on where she is, when to deploy the parachute. Previously, we used to deploy parachutes, that supersonic parachute, based just on navigated velocity. But now Perseverance has the smarts to figure out where she is and deploy that parachute at just the right place to make sure that we shrink where we could come down. That actually reduces the area, that error ellipse, where we can come down on the ground, from something that was on the order of 15 miles long by 12 miles wide for Curiosity to about 5 miles long by 4 miles wide for Perseverance. So that's quite a bit of reduction. Second, the next piece of technology that's helping us land there is terrain relative navigation. In the past, after we've popped off the heat shield, we've taken pictures of the ground as it's been coming up, but we haven't really done anything with them. This time, Perseverance is carrying a camera to take pictures, but also a kind of second brain to help it figure out what those pictures are telling it and match it up with an onboard map from a satellite. That allows it to figure out exactly where she is. Suddenly then, she can then fly to safe spots that are nearby once she really knows where she is. It allows the site to not have to be as flat and boring as a pancake as some of our past sites have been, the entire area we could come down. Now we just need little pieces of that site to be small enough and safe enough for us to land in safely and fly there after we've gotten rid of the parachute.
And we also have a social media question coming in. Sansakari14 on Instagram is asking, how does the sky crane decide where to move itself after the payload lands?
After the payload lands, after the rover touches down, the sky crane, the descent stage, which is that rocket-powered jetpack above it, the first job, of course, is to make sure you don't hurt the rover. So it'll turn forward or backward so that the engine plumes don't pass over the rover. So it'll come up and start to turn. And it'll go in whichever direction is closest to north. So it can either go forward, if that's the way north is, or go toward the rear of the rover, if that's where north is. And it'll fly about 1/3 of a mile or so away.
Thanks for talking to us today, Al.
Thank you very much.
Now, let's head back to Mission Control for an update from Swati.
Hi, Raquel. So remember that command that we sent at around 11:35 to turn the transmitter off? We are just about to get confirmation that Perseverance has received the command. The command took 11 minutes to go to Perseverance, and then the reply took 11 minutes to get back from Perseverance to the ground. So we should hear any second now that we have officially turned off the transmitter. And after that, we will be about 4 minutes from the start of entry, descent, and landing mode. At this point, we will transition from the cruise approach mode to entry, descent, and landing. And that means our travel from Earth to Mars is done, and now we just need to get to the surface. So far, things are looking good.
Great.
Hello, this is CAD 3, ready to show estimated miss distance for OD 132.
Copy, EDL phase, we'll come back.
Go ahead.
Flight Ace. Go Ace. Our tracking stations have all confirmed the results of the transmitter drive off and in lock one way. Copy Ace. GDS flight. Flight GDS. At this time, I'd like to disable the alarms before EDL main. So please disable all the alarm files and start a new downlink session.
Copy that.
EGP.
Copy that. Proceeding now.
And confirmation that we are now officially one way and the transmitter is off.
Rover mission has helped shape the other, starting with the landing of the Pathfinder more than 20 years ago, leading up to where we are today with Perseverance. Perseverance Deputy Project Manager Jennifer Trosper has worked on every Mars rover mission, and she joins us now. Jennifer, how does Perseverance fit into the history of exploring Mars?
Thanks, Raquel. It's great to be here. Well, Perseverance is NASA's 5th rover on Mars, and I've had the privilege of working on every one of them. And the very first rover was the Sojourner rover we sent in 1997, and it was the size of a microwave oven. And even at that small size, Sojourner was able to transform the way that we explore Mars, from stationary landers to small roving robots that go from place to place, just like a geologist would on Earth. So once we had that roving capability, then we sent our twin rovers Spirit and Opportunity. Spirit and Opportunity were tasked with finding evidence of ancient water on Mars. Now they did. They're great explorers, and both of them found ample evidence that water had once existed on the surface of Mars. But we had a question. Another question then was, Mars ever habitable if water had been there? And that's when we sent Curiosity. Now, Curiosity was a major upgrade to our rover fleet. She's the size of a small car. She landed with the Sky Crane system instead of airbags. And she also carries along her own sample analytics lab, and she's still operating today. And during her exploration, she has found evidence of a habitable environment in an ancient lake bed on Mars. So now we're sending Perseverance. Perseverance is tasked with answering the question and looking for evidence of ancient microbial life on Mars. And in order to do this, she has to be the smartest and most capable.
Yeah, I think we will reduce the volume and we will officially
How Perseverance
start
is
with
smarter
the
than its
event.
predecessors?
Yes, we've made a lot of upgrades to help her along with the surface mission. One of them is for her autonomous traverse capability. When I say autonomous traverse, I mean we tell her
I will
where
try
we want her
to
to end
add
up,
the
and she has to
clap
figure out
shields
the
as well.
safe and best way to get there. In order to do that, she uses her cameras, algorithms, a computer. So we've given her another computer, we've upgraded the cameras, and we've upgraded the algorithms. Now she drives 3 times as fast as Curiosity could drive in this autonomous traverse mode. In
There is
fact,
Amit.
her average daily distance for driving.
Yes.
Yeah, Amit, are you there?
Amit?
Vaibhav, also try to slightly adjust the window because not all of them are visible on YouTube Live.
Right.
Not fully maximize the window. Yeah.
I can try minimizing the window.
Yeah, I think it's better.
So I'm just checking with Amit. There is some Wi-Fi issue that Amit is facing, an internet issue.
No problem. So I think we can start.
Yes. Okay.
You can join later.
Yeah.
So hello everyone. Welcome for the watch party we are organizing. So I am Chintamani Pai, co-founder of Space Geeks, and we are organizing this event in collaboration with Amity University, Mumbai. Siddharth, are you there? Yeah.
Hi, Chinta. I'm here.
So we have head of astrobiology center at Amity University, Mumbai, Dr. Siddharth Pandey, and it's very historic moment right now we are witnessing, we are part of, and I'm sure it will create golden memorable moments in our memory. And so right now we welcome you behalf of Space Geeks and Amity University, Mumbai. And first of all, let me thank Amity University for accepting our proposal to host this event. And with that, I also welcome our panelist today, Dr. Jane Blank. She is joining all the way from NASA Ames, US. And it's great pleasure to have you again after World Space Week celebrations. And in fact, I remember that during World Space Week celebrations, we had the topic of Perseverance rover and Mars. And it's great to have you again with the continuation of World Space Week celebration. So over to you, Dr. Jane Blank.
Oh, great. Hi, everybody. Yes, I'm calling in from Southern California. Half of the U.S. is covered with unusual weather, and some of my colleagues are without power, and especially in Texas. So my thoughts go out to you, and I hope you get power soon and Wi-Fi soon. But I'm happy to join the Space Geeks as we watch this historic landing event together. Now, Chinta, I don't know what you want me to say right now because I know there are other people on the line. So I'll just say that I'm a scientist at NASA Ames, and I was on the Curiosity mission team, science team, working with the first interplanetary laser ChemCam. So I have a lot of friends and colleagues who are part of the Mars 2020 mission, and I'm very excited to be watching here with you as a tourist. And while I have a sort of a sense of exhilaration and anxiety, I don't have responsibility right now, so it's really actually much more relaxing.
And yeah, so Vaibhav, can you hear me? Yeah, I think you're muted.
Yes, I can hear you.
Yeah. So it's my also pleasure to introduce Dr. Vaibhav Raut, who is also working at Amity University, and he's part of this event, and I must thank him for his support. And do we have anyone else from Amity? Any students from Amity?
Amit have joined.
Has
Amit have joined now. Yeah.
Yes, hello. My name is Amit, and I'm a final year BSc student, BSc Physics student at Amity University, and I'm quite glad to be here.
Great.
So Amit, I request Amit to officially introduce our today's speaker, panelist.
Sure, sir. So, Dr. Jen Blank, we welcome you. You hail from NASA's Ames Research Laboratory, and as you said, you have worked with the ChemCam in the Curiosity rover. And as you said, it's quite nice to not have the responsibility of having your own rover. But could you please talk to us a bit about how the lessons that we have learned from the previous rovers have affected our choices in making the Perseverance rover, and what resources might the Perseverance rover and the samples collected have that the Curiosity rover did not have?
Sure. Hi, Amit. Nice to see you and see some of the others of you. And it was great to meet. Actually, it's been great to see you, some of you in person during trips to Mumbai, which have not happened this year of the pandemic. We're getting ready for the landing of the Perseverance rover, which I like to call Percy. So Percy's going to Mars, and we have been developing, the world, but NASA especially, have been developing little by little the best way to land on Mars. As some of you may know, about 40%, only 40% of the landings on Mars have been successful to date. So being on Mars is hard, and landing on Mars successfully is also hard. So with the Curiosity rover, which touched down in 2012, we had the similar technology with the sky crane. So you have the shell craft coming in, popping out the front of the shell, and then down at about a few hundred meters, so less than a kilometer, the sky crane starts to lower the rover, which in Curiosity's case weighed about 900 kilograms. So we're using that similar technology, but with improvements, because Perseverance, while it's the same body of the rover, it actually weighs more than 1,000 kilograms, and so it's a little bit heavier. But also we have learned a few things with that successful Curiosity ADL. In particular, our angle of entry is a little bit steeper, and our parachutes similar, a little bit bigger. But the biggest change is that we now have more cameras on the shell and on the rover, and these are also transmitting, I guess, relays in real time, just to say that the rover is alive. But also, it's used the rover software is able to make autonomous corrections to the path in real time. So when the rover is in that final stage and coming down, it can fire rockets to actually move away from, in case the rover sees a hazard below, it can move away up to 600 meters to avoid that hazard. And the idea is that this will give it a higher chance of success if there might be some rock or some pit or something or some monster on the surface of Mars. So I think it's the big thing. It's called the terrain relative navigation. And it's a really new feature and very exciting sort of evolution in the autonomy of these missions.
Thank you, Dr. Jen. I'm assuming that this autonomous system that you've described, it has been part of the development of the autonomous systems, the AI systems that have been emerging in the autonomous driving industries. And I assume that since these corrections can be made autonomously, this might improve the efficiency of the rover, right? Because you're not waiting for any commands from us, basically.
Well, that's true. I think I listened to a very good talk by Rob Manning, who's the chief engineer at JPL, last night, and he talked about the evolution of entry, descent, and landing, or EDL. And going from the time of the 70s with the Viking missions to the Mars exploration rovers in the early 21st century, where they landed with the bouncing balloons, and then also how now we've evolved not only the autonomy, or rather the artificial intelligence assistance with the landing, but also our ability with the positioning and the sort of firing the little jets to grossly reduce our landing ellipse. So it went from essentially, I think they said it was a city the size, the landing ellipse for the exploration rover Spirit and Opportunity was an ellipse the size of Manhattan, so kind of big. And now it's about 8 by 13 kilometers. It's actually more similar to a circle than an ellipse for the landing site in Jezero. So that's a huge advantage also for positioning rover craft on Mars.
Thank you, Dr. Jen. We also have a new feature in this rover, which is that it'll perform the first powered flight on Mars, which is not something that's been done before, and it's going to give us a lot of information about how we might proceed in the future. Where do you see that going and affecting our ability to travel around the planet and collect more samples? Because drones will have a higher reach, and that is something that could be quite useful in the future. And how do you see that developing compared to the depth analysis of the planet instead of the wide range of analysis?
Oh, actually, thanks for bringing up the helicopter, because first of all, the name is priceless. Ingenuity. I think it must have been named after me. Well, that's what I tell myself, even though I know that's not true. I just changed the spelling a little bit. But yeah, this is so cool. This is NASA has sent along 2 proof of concept instruments, And Ingenuity, or the little Mars helicopter, is one of them. So Ingenuity only weighs about, I think, 2 to 3 kilograms. It's very light. It has a solar battery on the top. It has wings that are, I think, about 1 meter in diameter. And right now it's tucked under the bottom of the rover. So I'm thrilled. And actually, I don't know if any of you have had a chance to look at some of the educational packages that are at the NASA website that accompany the landing event. But it shows there are videos that show how essentially the little protective shell will drop off and the rover will drive away, and then the helicopter will unfold from the bottom of the rover. And the idea is just to launch up to 1,000 feet, I guess 330 meters, and do very short sorties. But I think if this works, right? So NASA sets the bar lower so it can achieve these goals. But if this works, I mean, gosh, we'll be able to cover much more of the surface. And in fact, if we have a solar powered helicopter, we could do this for long periods of time and get a much better, higher resolution view of the surface of Mars. And actually, see behind me right now, I have these are some lava tubes on lava caves on Mars, and they're in a part of Mars that is high elevation, so it's hard. NASA can't land there at this time. But in the future, I hope we'll use small helicopters to actually check out features like these lava caves, and other features on Mars, and without having to bring a 1,000-kilogram rover down to the surface. We can bring a whole swarm of these helicopters. So I'm very excited about that.
Well, thank you, Dr. Jen, for sharing your insights with us. Dr. Webber, could you tell us if the other panelists are with us?
Yes, Amit, we currently joined by Jen Blank, and we have Dr. Siddharth Pandey from Center for Astrobiology, Amity University, and Chintamani Pai, as he introduced, Space Geeks, and we have an Ankush Bhaskar who works in space weather and other aspects. So Jonathan Clark, Dr. Jonathan Clark have been joined yet. So we are.
Yeah, I just messaged him. He'll be probably joining in sometime very soon, shortly.
I think we're okay with the NASA feed. They're asking
Yes, Chinta?
questions.
Yes.
Maybe Siddharth, you can put your thoughts and how you are feeling about this event, and as you are part of Astrobiology Center at Amity, how you are looking at this mission and what are your thoughts on astrobiological aspects of Mars?
I think first off, even the fact that we have this particular mission has reached so far is very exciting. It is already a victory for the team to have successfully won the proposal. I don't know how many years back, almost maybe 10 years back, when they must have prepared for this proposal. They won it, they got the money, they put together a team, they built it, and they launched it, and it has reached Mars. It has already approached Mars. So it's, I think, already a lot of work has to be applauded for, given how difficult it is to maintain these long-term projects and the large teams and the way people work. So it's a lot of work that's already done. Now from here is where things get interesting, and also for Mars, it is pretty much the first final frontier, I think I can call it. um, we will be very, very lucky to be able to re-achieve what had been achieved way back in 2013. Uh, as Jen was mentioning, that the hardware is pretty much similar to what had flown in 2013. But yes, there are certain modifications. And even I think if it was the same piece of hardware that had been sent, we cannot say with full, confidence that it would be achieved the same way that it was achieved in 2013 by Curiosity. So there are always challenges and there are always things that kind of go against us. So that is one thing to keep in mind. As far as our work is concerned, I think there'll be a lot of scientific data that will be coming out of this specific mission that would be very exciting. The crater in which this particular rover will be landing will actually be telling us a lot about how craters can actually be or cannot be good places to look for life. So astrobiology is a very tricky thing to achieve by a robotic mission, as we have learned. Every time we discover things, we also we find out questions. We find out new questions to be answered. So they will not just be answers, but perseverance will also be uncovering new questions to be asked. And that is actually another very exciting thing, to be able to find more questions to think about, to ponder about. And that is the whole objective of science, right? It is not that we are going there and we are going to identify everything in this one mission. It is a constant process. It is a scientific process. In terms of the work that we are doing, I think it will be also relevant to mention that there is a crater in India, in central India, called Lonar crater, which some
Right.
of you must have heard about. And this crater is actually very, very important and special because it will allow scientists to, in the near future, train for future missions to craters on Mars. So craters are places where you have a collection of water over a period of time. And similarly on Mars, the craters that we are seeing on Mars, at one point of time, some of them were actually filled with water. They had lakes and standing water bodies. So we look at how these geological formations are actually creating ideal environments for biology to evolve, right? So that's one exciting thing about India, that we have a crater site where we can actually train for Mars. And aside from craters, we are also working in Ladakh. And currently, we have just, in fact, few minutes before this call started, we have actually uh, released another teaser post. And tomorrow morning is actually the time when we will be opening up registrations for all participants to actually experience working and being in an environment which is similar in many ways to Mars in Ladakh. So this project will be launched, and Amity University is very, very excited and looking forward to hosting students, space enthusiasts, researchers, anyone and everyone. We are looking forward to people who would be, uh, excited to travel and visit Ladakh. Of course, within the COVID norms and regulations. That is something that we are taking very seriously. And domestically, we are seeing a lot of people are moving out and traveling around. So, based on everyone's comfort levels and interests, this is an opportunity that exists that I'll be happy to talk about if there are questions. So, those are some of my initial thoughts about the environment right now. And it is always exciting to have these kind of events where even if it is in the middle of the night, we are all awake and we are all looking towards Mars and trying to uh, hope for the best and ensure that we are having a successful landing in the next approximately 35 minutes or so.
We all are grateful to have such a lovely participation, that we are having around 42 participants overall for this watch party.
Yeah.
Uh, Thank you everyone for joining us. And since Dr. Siddharth spoke about Lonar crater, my question to Dr. Jen Blank is, so how do we look at the Lonar crater from Lonar crater's perspective? And now we know that this rover will be actually landing in the vicinity of Jezero crater, and it will be spending around 2 years time. So what are we looking at, and why this Jezero crater was chosen for as a landing site?
Is that a question for me, Chinta?
Yes, yes.
Okay. So there are actually a lot of questions in that one. Why was Jezero chosen? Well, first of all, it was anyone in the community around the world could suggest a landing site, and then little by little, the suggestions or arguments for the suggestions were vetted by the scientific community, and ultimately the choice of Jezero was made at headquarters. so NASA headquarters. Oh, I love this. I love this. Sorry, I'm distracted by by the great picture of the NASA photo booth. Here's another one you can see. I put the link on the chat so you guys can all add your own. And I also add an example of one with some sheep from my neighborhood. Anyway, back to the Jezero crater. So Jezero crater is pretty wide. It's about, was it 25 kilometers in diameter, and it has, actually maybe I think it's bigger. But it's essentially, we think it was filled with water a few billion years ago, as evidenced by the sort of deltaic fan, which is evidence of very fast, rapid transport of sedimentary material into the crater. So when you have this sedimentary material coming in quickly, i.e. quickly over geologic time, you have a higher likelihood of burying any organic matter that might have been there. So the thought is we could look at this these delta features for organic material and look for further evidence that there might have been life on Mars in its early history. Did I get all the questions in that big question, Chinda? Did I miss something?
And maybe around Jezero crater, is there any like probable sites where we see that if there is some if there are porous rocks, do we expect that those are the most kind of probable sites for detecting any signs of microbial life?
So you're saying would we look for it in the porous rocks?
Yes.
Well, a lot of the sedimentary rocks we see on Mars have the chemical flavor of igneous or volcanic rocks we see on Earth. And those have more or less porosity, but that a lot of those pore spaces would have at least in Gale Crater, where Curiosity is exploring, have been filled by cements or very, very small, fine-grained sedimentary materials. So I don't think we'll be looking in the pore space, but that's a great suggestion in terms of where life might exist, right? In the open and fresh surfaces between grains of rock. So essentially we'll be looking at a slightly larger scale using the Sherlock instrument that's on the arm of Percy. And this can look for fluorescence that is indicative of organic material.
Right. Thank you.
I can show you some information if I may, Chinta.
Yeah.
Can I share my screen?
Yeah.
Just for 2 minutes. I know everybody is.
Yes.
Okay.
Just a moment.
I think I have permission.
Okay.
All right. So don't get overwhelmed right now. Just to answer the question a little more, because I was doing a bit of an analysis for another project. This is how detailed it can actually get when you're talking about selecting a specific site. So don't worry about all of the information. Just focus on landing site criteria. So if you look at this column here, you see this number of sites that were selected. This is actually out of a paper that was published, 3 years back, from the findings of the final landing workshop. So NASA conducted an entire workshop where teams of people could actually present their case for each of these sites. So you see Jezero Crater, Columbia Hills, and East Iris, Certis, and similarly like that, there's several different sites. And some of the sites actually where other rovers are landing are also here. So if you look at Oxia Planum, that's one of the sites where the European Mars rover will be landing. And look at the different categories under which the scoring has been done. So for example, geological setting, ancient habitable environment, biosignature preservation, quality of the return samples. So what kind of samples you're able to collect, because that is the other objective of this mission, that it will be collecting samples, it will be keeping samples. And it was scored on 5, between 0 and 5. So over and above, Jezero managed to get a really good score. And on the right side, you can see the top 6 sites, or rather, sorry, the 4 sites, and 1, 2, 3, 4, 5. No, top 6 sites, and they were graded against for different for each of the different topics. So like in situ science, returnable cache, and things like that. So this is a paper by J.A. Grant et al. If those of you who are students who would like to get more information,
I think that's 4 sites, right? The final 4 sites.
Yes, that's the 4 sites. Yeah, right. Final 4 sites that were compared against each other. So there's a lot of discussion where people wanted to go to Columbia Hills, which is actually visited by the Opportunity. Was it the Opportunity rover, Jay? The Spirit
Yes.
or the Opportunity?
Spirit, sorry, Spirit.
Spirit rover.
Spirit, yeah.
Yeah. So that was the other site which people wanted to revisit because of the findings that were made of certain hot spring sediments, ancient hot spring sediments, which could have perhaps been also very promising. So it's always debatable, and it is hard to choose. But they try to find ways to objectify the selection process and eventually choose.
What's so interesting about that is that the people who are really promoting going back
Yeah.
to Columbia Hills, right, were people who were not NASA employees. They were scientists from some from the U.S. and also from New Zealand and Australia. But it
Yep.
just shows very, very good geologists who had spent their career
Yep.
studying essentially hot springs and ancient life. And so it was really interesting. They were this group who came sort of kind of as an unknown group to the initial meetings in the community were able to little by little, because of their expertise and their ability to articulate the motivation going back to Columbia Hills, came so close to actually influencing the choice. And Columbia Hills Spirit found high silica, so we definitely know that. And some pictures that look almost like geyserite or some kind of silica materials that we see around hot springs like in Otato, Chile, or in the South Island, New Zealand. And so that's pretty cool. But Jezero Crater, by and large, was determined to have the highest probability for detecting new forms of organic material.
Yep.
So yeah, that's a cool diagram, Sid.
Yeah.
And it took many years in the community, and even the end. I mean, not one, well, once headquarters selected a site, then we all jumped on board to think, now let's site. But that, for example, that wasn't my first choice.
Yep.
But I was outweighed. Anyway, but it's really exciting. So we had a question. Sorry, we had a question from Jay, someone named Jay. Hi, Jay, about EDL physics and or EDL. And I have to say that I'm not an expert, but the question is, why does the spacecraft have to despin before EDL initiates? Doesn't spinning increase flight stability, or are there any disadvantages to spinning during EDL?
Because you have to control the spacecraft, right? Spinning is stabilizing.
I have to say that Sid has a degree in aerospace engineering, so I was going to pass that to you, Sid.
I'm not a EDL engineer or a scientist. Again, I need to put my disclaimers as well. I don't wear so many hats, but I'm just based on I've done flight stability and control, so I know a little bit about stability and control. Spin stabilization, yes, but once you're entering the atmosphere, as of now, I think most of the spacecraft, when they are entering, they do not have a spin. They are what would be the right word, under de-spun or something. So basically you stop the spinning and you use your active control systems, your thrusters, to orient yourself in the right angle at which you need to enter, which is very, very crucial. So the the trajectory correction maneuvers run into very small fractions of degrees. And to achieve that, you have to make use of active thrusters, so which are basically
Sid,
small engines.
excuse me, Sid. Okay, that's interesting. But I would also think, just from I guess, an observer's point of view, you wouldn't want to deploy a parachute if the craft was spinning, right?
Yeah,
and
but I think no.
so
But the
that's one.
question is, before you even reach that stage, when you are going through the burning of the when you're entering the atmosphere at that particular point, you could argue that you can maintain a spin so that you don't have a lot of unstable movement in your flow path.
Yeah, maybe I have something interesting to share from NASA resource. So you can actually see what is the current status of the spacecraft.
Oh, let's see. So how far we are now? It's 12:35. So we are. What is? It's sorry, 12:35 my time. So we're
just. Can you see my screen right now?
Yes, that's great.
Yeah, so that is what actually is happening right now, and you can see the live. So as it is getting entering the Mars atmosphere, you can actually, so this is a website called eyes.nasa.gov, where there is this Mars 2020 app, and you can actually go through all the sequences as the rover.
Let's watch this. I know that for MSL we had this, the Eyes on NASA on the screen, and we all sort of watched even though there was a delay. Does anybody know what the delay is right now between Mars and Earth?
Yeah, so maybe Vaibhav, can we switch to NASA Live right now?
I like this though, but it's about 11 minutes, right? So EDL, as someone mentioned, EDL is this refers, or the 7 minutes of terror refers to that transit time once the craft begins that descent, and we lose immediate telemetry.
Correct.
So we have to wait not only for the 7 minutes where we don't know, is it going in, okay, or is everything working, which we assume it's going to work, but then we have to wait for the delay once the craft is on the surface, once the rover is rather, to ping back to Earth. And I guess the Mars Reconnaissance Orbiter is going to take the initial relay back to Earth, and then also MAVEN will be observing. MAVEN's the Mars atmosphere mission that's been on Mars, or been another orbiter on Mars. So it'll take 11 minutes to get back to Earth, plus those 7 minutes of terror. So what is that? 18 minutes.
Yep.
Before we know, did it go or not?
Yep.
Or it didn't. I know for the last mission for Curiosity, I bet with a colleague of ours who's no longer with us, David Wilson. Do you know this, Sid? And we bet $1. So we both thought that the rover would land on Mars, and I thought it would land perfectly, and he thought it would land in a smash. And so thank goodness I won, and he gave me $1 Australian because he's Australian.
So as per this side, as per the live data, it is showing for touchdown we have like 17 minutes 30 seconds from now.
So does that mean it's already touched down?
No.
So notice Jay says also, this is a very cool simulation. I agree, but note it's not live, right? It's a simulation.
Right.
It says live, so they're replaying it live, and it's always where it's a little bit confusing. So is it really 2 a.m. where you guys are?
Yep.
I think if I played it, it would say a different time.
It is showing Indian Standard Time.
Well, so Jay says, thanks for answering the question. I don't know if we really answered it completely, Sid, but I think you know more about this than I do.
Yeah, stop sharing and we can move to NASA Live.
Okay.
And
so what time is it actually supposed to be landing?
Oh, look, it's separating. Look, it's separating.
Yeah.
So it sheds the crew stage, which houses the solar panels, sensors, and fuel tanks. So when I was looking at a mock-up, or rather a model of all of the cameras inside this housing, I saw a GoPro. So I thought that's one way NASA saved money, by buying a off-the-shelf product. And it wasn't the only. I mean, sorry, the GoPro is not the only camera. It's one of maybe, I can't remember exactly how many, 14 or so. Because they have a lot of cameras this time, looking inside the shell, looking at the rover, from the rover looking back. So they're going to have a lot of coverage, and we're going to get a lot of great imagery during the landing process. Let's go to NASA Live, says Anrup. It's pretty interesting. Yes, let's go. Chinta, I like this one. We can see everyone on the screen up above. And then can we go to NASA Live for the main screen? That'd be cool.
Vaibhav, are you there?
Yes. We'll go to the, sorry, I'm just don't have the video feed.
So Chinta, how many members of Space Geeks are there?
So right now we have Vaibhav, then we have Hari, we have Ankush. So Ankush is joining all the way from ISRO. He's right now working as Inspire faculty in the VSSE, and he works in space weather. So he's joining right now. And Ankush, can you say a few words?
Right, let's have, okay, go ahead, Ankush, and then someone, maybe but you can get the NASA Live feed up.
Yes.
Yeah,
yes.
I think someone better put NASA Live in between. We don't want to miss.
We don't want to
Absolutely.
visit.
Yeah, so okay, I generally work on space weather, so even Mars is very interesting in terms of solar wind interaction with its atmosphere. Uh, and anyway, this going to be landing, so we don't know. We can't get more measurement about that. But I still have a question. Can we get something like from geological samples, how the solar wind interaction happened in the past? Is there any way we can dig out some
So are you
signatures?
asking about, a
Because
weather from samples? Oh, here we go. Here's
yeah,
the
yeah,
DC is happening right now. And here's mission control at JPL. Okay, that's exciting. They're all wearing masks. I would have thought they might have had, and they all have the Mars 2020 mask. I would have thought they might have been tested.
Just I'm sharing it again because I just want to share the audio as well. So yes.
And can control its orientation and attitude via rockets on the back of that back shell.
Points carrier lock. Sorry, DTE from Radio Science from Green Bank.
Okay, it says atmospheric entry 7 minutes.
See the carrier on the downlink.
But Jen, is this 7 minutes for us, or is it 7 minutes on Mars?
We are continuing to wait for entry interface for about 6 minutes and 45 seconds for entry interface.
I'm not
we have confirmation from Greenback that they are receiving direct to Earth telemetry via that path. The spacecraft Perseverance is currently transmitting heartbeat tones. These tones indicate that Perseverance is operating normally and has nothing significant to report.
So this same speaker said that we would get heartbeat tones during EDL.
Over 6 minutes
That's
from
new.
entry interface.
Just a ping, no other information than that the rover is still alive.
So my question is, has this already happened and we're just waiting to hear in 6 minutes?
And
Or
I said I'm not sure exactly. It's supposed to,
As soon as we get to the top of the atmosphere,
Someone in the chat says that it has already happened, and it is that we are waiting for the information to get.
That's what I think as well.
thicker and thicker. It's going very quickly at a fairly steep
Hey,
angle,
Mark.
50 degrees.
Mark Purita in the house.
And as it starts to slow
We're
down,
just under, we're about 5.5 minutes from entry interface. We're still receiving heartbeat tones. We expect to continue receiving heartbeat tones until about 5 minutes after entry. At that time, Perseverance will be no longer in view of our antennas here on Earth. About 90 seconds prior to entry, the Mars Reconnaissance Orbiter should begin receiving telemetry from Perseverance and streaming it to Earth in near real time. There are a few expected short outages, such as when we have a plasma blackout or when we enter the peak heating phase. Aside from these outages caused by the plasma blackout, antenna switching, or high dynamic events, spacecraft events, we should have telemetry until about 90 seconds after landing. A plasma blackout is when the signal from Perseverance isn't strong enough to make it through the superheated, super fast air blowing around the spacecraft all the way down to Earth. Once the temperature drops below that peak heating, we do reacquire the signal from Perseverance. We are currently about 4.5 minutes from entry interface. Perseverance continues to report heartbeat tones, indicating everything is nominal.
okay.
So just that's great. So just
We're
in the
looking
notes,
for now is Mars Reconnaissance Orbiter should be in view soon of our vehicle and be able to listen to ones and zeros coming from a separate radio that's really designed to talk to the
so we're
spacecraft.
essentially getting the
Camera
stream.
report, the electro radio is powered on, ready to receive signals from the lander.
Okay. MRO is ready and able and waiting for to hear from our rover.
Mars Reconnaissance Orbiter has reported that
I'm really curious to see how the engineers are going to respond when we get to that.
it should be 6 minutes here. We're just late local one from entry interface.
We don't need these ones and zeros, as Swati said, but to land safely, but we really need it for our own health and well-being today to keep our nerves under control. But
around this time, a second spacecraft should
no.
begin picking up telemetry from Perseverance and will continue to record that telemetry until several minutes post-landing. We won't get that data for several hours after landing as it's being recorded and then will be forwarded to Earth later. We are continuing to receive heartbeat tones, indicating that everything is nominal. We're currently at about 5 minutes until entry interface.
Okay.
We're having 7 minutes of terror right now.
Very soon we'll be ones and zeros, I hope, from our radio on the rover.
Atmospheric entry in 3 minutes.
Hey, Anirudh, did you listen to my Mars playlist? Everyone, I made a Mars playlist on Spotify.
I love it. It's awesome.
Combination of Mars songs and other songs I feel like adding. Anyway.
I'll share the link right now.
Oh, no, it wasn't. It's nothing special. It's just it was fun to do.
So maybe.
Hey Rakesh.
Indicating everything.
Dr. Mogul in the house.
In the house. What's up? What's up? What's up?
Oh my gosh! Look at your hair.
Dr. Rakesh Mogul.
So the vehicle thinks it's helping.
Yes, he's calling from California also.
Yeah.
So the tones to tell us.
So Dr. Mogul has been running Spaceward Bound in Mojave in the US, and he was also in Ladakh with us in 2016. And he is awesome. He does everything the best way it should be done.
Ask him about signs of life on
Perseverance is actually being pulled in by
Yeah.
gravity.
Yeah, why are we going to Mars? We should go to Venus. Just joking. Let's go everywhere.
Wrong party, Rakesh.
Well, so
We need to go everywhere.
wrong party. I guess don't go
Wrong
anywhere.
party.
We have a few people who took our who took the Amity astrobiology course online watching with us, and that's wonderful. Hey, Logan. Oh, that's cool. Oh my gosh! No, I just remember with Curiosity, we were all of the science team was in the basement of the flight ops building at JPL, and we could smell the energy in the building because the engineers, all the light blue shirts, were upstairs on the 3rd floor, and then we had a few people on our team, like the chief scientist, who could go up and forth, but the rest of us are kind of trapped in the basement, watching this simulation countdown because we were sort of wondering what's happening.
1 minute on entry interface.
So buzzing with energy.
So less than 1 minute for atmospheric entry now.
Yay.
So another bit of trivia for some of you who might not know this, but most of the sites that are chosen to land and
receive mode.
operate on Mars are actually quite low. And that's because you want to make sure that you get enough atmosphere to go through. So you don't want to land on top of a mountain on Mars. You want to land somewhere in a valley or a canyon, or not a canyon, but like at the bottom of a crater. So you get enough
Here we
atmosphere.
go, people. I got 14 seconds on my side.
Oh.
17, 16.
Yeah, 15.
And there we go.
I've got 5 seconds on my side.
Why is your clock different? Is
He's-
it's a time delay?
150.
He's probably on his way to Mars.
No, but that's right. So right now, these sites, most of the land sites have been actually below the mean elevation on Mars, or what we call is below sea level. So there's no sea.
We have confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars.
Looking good.
120 kilometers. Wow.
Hey, does anybody know how to see this this window that they have there with all that data?
Is now waiting.
When we're watching or something else?
Like what's on your screen right now?
It's a live YouTube stream from NASA.
Is there a website just to see those stats?
I think the website eyes.nasa.gov had the same stats displaying.
Navigation is also.
Can you put that link in the chat?
We can see a little bit of
just give me a second.
slowdown of the atmosphere on the Perseverance entry capsule. Our current velocity
There's definitely a delay. I'm about 5-10 seconds ahead of you guys.
kilometers per second and an altitude of about 67 kilometers from the
Here's
surface.
the there's the Mars.
Plasma blackout.
Okay, so I put the Mars YouTube line, the link, and then Rehan put the Eyes on NASA one, which I think is what we're viewing on the Mars channel right now.
It should be doing its turns right now.
Amarillo has lost lock.
Hey, thanks for that site. It's super cool.
We have indications that Perseverance is now performing bank reversals in the atmosphere. These are the steps
If
in order to
participants, if they have any
control
questions, they can ask
to the landing
experts
target.
here.
Do you want to
Perseverance has
share, Chinta? Do you want to
passed through
share
the
the
point of maximum
eyes
deceleration and
screen
has
right now?
indicated
Okay.
that
I'll
Hey,
share.
keep the background
approximately
noise from NASA, or
10
sorry, noise, the
Earth
discussion
Gs
from NASA.
deceleration.
Amarillo has lock again.
Yeah, so this is the
We
view
saw a
on
small
my
outage
webpage.
of
If you go
the
to the NASA website, it shows the current stage of that
orbiter
video.
during that
Yeah.
peak heating phase
Can you see it now?
caused by the plasma blackout.
We're just seeing the flight.
Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target.
And yeah, so it's live right now.
So if you look at the eyes channel, are you looking at that?
Perseverance is going
You
about
want me to
1
go
kilometers per
to
second
refresh the page,
at
or
an altitude of about
I think it's
16
showing
kilometers
live.
from the surface of Mars. We have
So
entered
first
heading alignment,
per second.
which means Perseverance is no longer trying to control the distance to Mars, but in
And they'll slow down to 2.5 miles per hour, which is what in kilometers per second.
You're sharing this.
Yeah, now it's going to like 1,100 miles per hour.
Yeah, it's slowing down.
So it's
8.6
it's
miles.
going to have to slow down to 0.001 kilometers per second.
Look at the altitude drop, 8.3.
Is everybody watching this? Oh, someone, Raghav says 3.35 minutes to touchdown.
and 50
Yep.
meters
Yeah.
per second.
You know, but which time? It's already happened, and we'll get it in 3 point. There you can see the parachute strings. That's
We
cool.
we see 240 here on the eyes.
Okay. I saw some video yesterday of the parachute testing in the wind tunnel at NASA Ames, and it showed some of the failures.
You're starting
And they
to
were not pretty. Just
right
being
when you're
parachute.
where the spacecraft will jettison the entry balance masses
Yeah, I think
in preparation for parachute deploy.
2 minutes, 2:20.
The
I
radar
think the
air
heat
look at
shield
the ground.
has been removed.
If there was life on Mars, I'm assuming it was it to be an organic life form.
All good news. Chutes open.
And the
Yeah.
velocity is 440 meters per second.
So 20 seconds after the parachute, the heat shield separates and drops away. There we go. But this is, remember, this is simulation. But you can see the rover now.
Perseverance is now slowed to subsonic.
Dr. Jen, you were talking about organic life on Mars. Please
I'm
continue.
reading a question from Naman Hirwani saying, can we detect fossil fuels on Mars?
145 meters per second.
Gosh, you know, that's a great question. And so far we've had no indication of that. And we think if there was any sort of abundant life, it would have been a time when there was water on the surface, and that would have been over 3.5 billion years ago. So it'd have to be pretty deep. One cool thing about accessing the Mars interior is we have a drill on this rover, and then we also have the RIMFAX instrument, which is the ground penetrating radar that will be able to look for water, ice, or even water, or other features in the subsurface. Ooh, look at that parachute.
Now has radar locked.
Here we go. Here we go.
Is about 100 meters per second. 6.6
Yeah,
kilometers
so
from the surface.
there is a backshell separation now.
Yeah.
What's the environment like in the room? Can we look at the people as well?
On the initialization.
They look so intense, and they have their masks on, so they're very quiet. I mean, it wasn't moving. I don't know. Can we? It's a good point, Chinta. Can we see both? Is it possible?
At an altitude of 4.2.
If you're sharing,
can you share quickly the?
Can you like share two screens at the same time, like split it?
That the lander
37 seconds. Oh my gosh! Let's see the people in the room.
Terrain relative navigation.
Okay, now they're clapping.
Yeah, polite applause.
I know.
I thought they'd be tearing their hair out.
Current
So
velocity,
polite.
83
Wow.
meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are
Oh, that's
currently
the black shell saying it wasn't the landing.
current velocity is about 75 meters per second at an altitude of about 1 kilometer off the surface of Mars.
About a kilometer.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars.
Okay, it's happening.
Tense moment.
We have started our constant velocity.
Well, I think they're so close now, it's going to work.
Sky crane to conduct a sky crane maneuver.
We've lost direct to Earth tones.
Okay, so they've lost the heartbeat.
As expected.
Sky crane maneuver has started. About 20 meters off the surface.
Wow. There we are.
Well, and you know, they separate the sky crane with explosives.
Signals from MRO.
So there are explosives on this shell, or the shell.
Pyros, yeah. It's on? Rakesh is already celebrating. Oh!
There we go,
Wow.
Oh,
Yeah.
They're touching. We landed.
At this point, the descent stage has flown away to stage distance. Perseverance.
No, they make it look so easy, don't they, guys?
Absolutely.
Oh my God, they make it look so easy. You
Oh,
think this
God.
is 11 years worth of work or something? Or careers worth of work. Hey.
So exciting.
They're not supposed to touch.
When do we get to see an image? Like in a few hours?
Well, they'll have a thumbnail probably in about 11 minutes.
They probably wait for the dust to settle or something?
Yeah, well, they'll have a thumbnail probably within 15 minutes, and then Maven will send more data later. So there's Rob Manning. He's the chief engineer.
This is so exciting.
Wow.
The participants.
Numbers just an added to Martian red pages. Do you guys know how many rovers are on Mars right now? Dead or alive?
We might get some pictures.
Hey, Mark gets a gold star. Right, Mark.
Maybe I can request few participants to share their thoughts and share their experiments.
Yeah.
Please share.
Just heard the news that Perseverance
yourself
is
and
alive on the surface of Mars.
share your excitement. Maybe are you feel? I'm sure definitely you're not feeling sleepy, but you can share your excitement.
That is as expected.
Do you want them to share their video or do it? Okay, Linda says congrats.
Because this experience of landing, because we were experiencing this Chandrayaan landing in 2019, in fact, and you know that sense of fear and anxiety when it is, in fact, you can sense that the spacecraft is very close to the surface of the Mars, in fact.
Congratulations to the mission. And looks like we have some more news in. It looks
So someone, we're talking about the.
Is that an image?
Yeah, that's an image.
Oh my God.
No. Was it already? First image.
Yeah.
Okay, here we go.
Very there.
I have the target point on the map when you are ready. We are ready.
Let's see.
Go for it.
Oh.
The same. Oh, all right. Yeah.
That's the Zero crater. That's not the image from the rover, right? The one on the screen.
The one on the screen. No, that's not it. Oh,
Yeah.
is it the same image?
Woo! Yeah, that's so cool.
What are you looking at, Rakesh? You're always like
You'll
5
see it,
seconds
you'll see
ahead of
it.
us.
Yeah.
It's right there in the background. See it? Now it'll come up.
Ah.
There
Wow.
we go.
Oh, here you go.
We'll get a much better image here. I mean, what was so cool about Curiosity is that the way that rovers oriented, we saw, hey, here comes John Clark. We could see Mount Sharp in the background. So one
I
thing they
think the
don't.
higher res photos coming later in the day.
Yeah, exactly. About
I think the
6:30.
first photos that come out have a dust shield on them anyway, so they're not as clear.
That's right.
Oh
Good
man, look
morning.
in the background in the next couple minutes. There's all sorts of images coming up.
Oh, nice and smooth.
Good morning, Dr. Clark.
See the heat map in the back?
Yeah, look at the heat map and look at the time.
Oh, yes.
So that I think that they said that it would be several hours, and then we start to see the big streams from higher bandwidth transmission.
Steve?
First thing was just to make sure it got down, and we had a view. Standbys for Steve.
Image also has come.
We have incredible, beautiful. Teresa says 4 p.m. in the East. Okay, that's right.
I don't know what that is.
10 p.m. in Italy. 5 a.m. 5
I don't
a.m.
know.
in Australia. John Clark, I think I saw your image. Are you there?
Yeah, John's there. He's just excited and not talking to us right now. He's looking at all the images.
Already started
Mark
analyzing.
says, I read there were a large number of orbiters that were watching the landing too. Yes.
Yeah.
Maven was monitoring it, and MRO is helping with the relay back to Earth.
Our second image is
Image. Second image. Wow.
These we have a camera in the front of the spacecraft.
This reminds me of my shoebox camera when I was 12.
Yeah.
A little dirty because we've got glass covers over these cameras, but we took these seconds after landing, so there's still dust in the air from our landing event. So this is happening. This happened just seconds ago, just arrived, and this is really amazing.
As Mark mentioned, it still has the lens cover.
We even know where we landed. This is the most amazing thing. The vehicle has told us where it's landed because it figured it out. Son, NASA works. NASA works. And when we put our hearts together, we can succeed. This is what NASA does. This is what we can do as a country on all of the problems we have. We need to work.
So is anybody eating their peanuts?
I was just going to say, anybody spied the peanut jar?
Jen, tell us about peanuts. We don't know what this story is.
Oh,
So
well, this goes back to 1960s when they were launching rockets, and they'd had 6 failures. And so when the seventh one of the guys was really nervous, and I can't remember his name, and so he started punching a peanut, and the number 7 rocket was successful. So we're not superstitious, but since that 7th rocket, people show up with peanuts in the flight ops room. And so actually, these were sent to me by Caltech. This and a Mars bar.
Just what an amazing team.
I need peanuts during exam, says Anarup. That's great. You should try it.
And all the challenges that go with landing a rover on Mars, plus the challenges of COVID and just amazing.
Yep.
Still moving.
Yep. Yeah.
Hi, John. Can you hear us?
2012.
I don't think you can hear us.
Not 9 years. Yeah.
Execute a mission with new instruments, we discover new things and things we never thought we would discover. So that always informs our future robotic missions, both landers, rovers, and orbiters.
He joined.
This mission also has technology on it. One of the cool things is the Ingenuity helicopter. It's an experiment on this mission. But if it's successful, we can use it as an science observation platform by putting instruments on it, and also use it as a scout.
Yeah, I think he had joined.
And then just the intermittent landing.
Do you see Dr. Jonathan Clark?
Yeah, he's there. I just don't know if he can hear us.
Okay.
John, can you hear us? Earth calling John.
Mars Intermittent Landing Instrumentation, which is going to give us EDL information. We have the Mars Environmental Dynamics.
Probably on 5 different watch parties right now.
Size and properties of particles.
I know there were so many launch parties today.
And this is just an incredible mission because of the science and the technology.
I think the glass switches on the camera, I think they have invented a new technology where I can actually remove these particles from the glass by electrostatically charging the dust particles.
By Perseverance back to Earth to examine with state-of-the-art.
I remember reading something about that.
Academy for Academic Excellence. And my question is, do you think we could get resources from Mars to help on future missions, or even at the launching point?
With or without peanuts? Let's have a group photo. Hey, that's a great idea. Raghav says, let's have a group photo. Can we show everybody and have a gallery view?
Vaibhav, can you
Yes, I can just stop the screen
Yeah.
share and then we can go to the gallery view.
Gallery view. Yeah. So if
I think the gallery view is restricted to 49 or 50 or so.
Yeah, that's how many we have. So
I'm so pleased that you guys in India stayed up till wee hours.
it's not like we had an option.
Well, I think this means you qualify. That's like the right, you qualify to be a space geek.
Absolutely, we're all space. We're all.
Till 2 3 a.m. and watch the landing.
Next time we will launch. India will launch a rocket. You all will have to stay up as well.
Hey, let us know. I will be. I've been up crazy hours.
I remember you were up even for.
Should we all get our SBI t-shirts on?
No. Mukund
Oh,
still
this is so
wears
great.
this.
So great. So I can't see 48 people, but I can't. We have 2 pages of views.
Yeah.
So
Make your window bigger, then they'll all fit in.
oh, really? Okay.
Maybe
Actually,
we
my
can
window-
even
If you have a 4K monitor.
So 1, 2, 3, everyone is ready?
See Mars.
Can anybody who's not showing their video show your video, like Ashna and Satya and Rehan?
I'm
Why are
taking
you
some
last?
multiple screenshots. Let's see which
Yeah.
one comes.
Oh my gosh, look at this. This is great. And Chinta, are you taking screenshots?
Yeah, even I'm taking.
Yeah.
I'm trying.
Just a request to all the participants if they can keep their video stream on.
Kunal was on for like the longest time, and I think he slept off.
Ah. Who's
So-
S18B041?
Probably a student.
Hi, Alon. Good to see you.
Probably a
I
student.
see. I recognize some of the names from our class.
Yeah, there's several students from our class. I remember I see Raghav Gupta. He is there in our class. I think Mohammed Wahidi. I recognize that name as well.
Hey, can you guys raise your hand if you were in the Amity astrobiology class?
Yeah, all the astrobiology students.
You guys are so awesome.
Ilan Kulazi. Ilan Kuzali. I remember your name. Logan. Hi, Logan.
Esh Matra, Teresa.
Nice to see you, Logan. Philippe.
So
Yeah.
cool. Eileen, Teresa, yeah. Ilan, well, I see you and some other NASA working
These
groups.
are all yeah, some of our online astrobiology students.
That's so cool.
So great that you guys could join us at such short notice. I actually purposefully sent out notifications one day earlier because whenever I used to send things a week earlier, this wouldn't work. People would forget. So
Unless it gets on your calendar. Yeah.
yeah.
Start your day with a smile. I like that little logo from Sahaj.
Yeah. So this is great. And I hope some of you students are able to come to Ladakh this year, despite all of the current situations. We'll probably get to meet in person and do a lot more exciting stuff up in Ladakh. So we'll have a lot of the information. The registration information will be up tomorrow morning. We've just put out a teaser about that.
Rakesh, are you going to try to go to Ladakh this summer?
I'd like to. I got a lot of things happening this summer, so it might not work this summer for me. I'd love to go though. Sounds so fun.
Yeah.
Yeah, me too. With the pandemic, we still have a lot of restrictions in California, and I'm wrapping up a project. Well, I hope in lava tubes in Northern California. Depends if we can get there. I mean, we can drive there, but do we have permission? Is it safe, Naman, to everyone? Is the rover safe, or are we safe?
Or is that a reference to Marathon Man?
Oh, jeez. No, I mean, actually, that's a serious question. Naman, what do you mean is it safe? I think the rover's safe.
I think he was.
I think Naman. Yeah, I think he's talking about the COVID restrictions and the travel to Ladakh.
I think that's still being worked out.
So, I mean, as far as domestic travel goes, people are moving and traveling. So it's something that we're putting up as per your convenience and your decision. It's your decision if you would like to travel. From our side, our team will take full responsibility for ensuring that all the COVID guidelines are followed and safety protocols are in place. So that's something we're taking very, very seriously. That's something that Amity is taking very, very seriously. And we're partnering with Kunal and his team, and every day we're having discussions about this with regards to social distancing while we are, in the tents, reducing the number of people who will be staying in one single tent and things like that. And of course, there will be procedures in place in case there are cases. But having said that, Ladakh being one of the most remote places, and having personally been to Ladakh, I've seen how disciplined the people are in Ladakh in terms of how they're following the rules and regulations. So I'm quite confident that we should be able to have a good season as long as we're all able to be safe before we actually get there.
I guess you could just quarantine in Ladakh.
Sorry?
You could just quarantine in Ladakh.
Exactly. Where would be a better place to quarantine? But again, we don't want that to happen, right? We don't want people to get COVID there.
With a few people there, we want to be able to congregate.
Exactly. And things will definitely get better by June. I also feel that. So
did anyone have any nervous sweat? Is anyone nervous for the landing? You can confess.
Yeah.
I was excited, but I wasn't nervous because they just made it look so easy. Oh my gosh, I just can't think of, there are thousands of people, thousands of engineers who work to make this happen.
Yeah. And then now it will enable hundreds of scientists and their students and their researchers to get so much of work out. So let's think about that as well, right? Like just the way Curiosity did, it's just going to add so much more information out there. And some of the people who are listening in right now will perhaps be reading some of those papers that will be coming out in the year or so and getting inspired and empowering themselves to do great things. So I think it's
don't forget the sample collection and potential return.
Yeah, that's a big one for Mars.
So
we didn't really talk about the science, but I just put a link on the chat. This is in a couple hours from now. For those of you who are not going to bed tonight, some of my friends and colleagues at Los Alamos will be talking about science, particularly with the LIBS and Raman instruments that will be active on Perseverance, and also about the radioactive energy source that will be driving the rover.
They start to plan using Ingenuity.
Congrats again to the Mars 2020
Sorry,
Perseverance.
Chinta?
Plan to use Ingenuity for test flights.
A flight test
so when do they plan?
To use Ingenuity helicopter.
Right. I don't know when they're going to deploy Ingenuity. My guess is the rover will spend the first several days probably getting an upgrade in software and then checking out all the parts. So they probably won't move the rover for some time. And you maybe know that before Ingenuity can deploy, they have to drop the base protection jumps, and the rover has to move, and then Ingenuity.
Okay, yeah. Well, it's all over. That's great.
And it'll also be, I think, probably informed in advance, probably when they're planning to do it.
Because it's going to be such a big deal. I'm also really excited about Moxie.
Yeah.
Moxie's the converter that will convert CO2 to oxygen. Here's someone showing us a video of the Ingenuity.
See, Ingenuity is they're showing, so I just thought of sharing it. Yeah.
See, did you guys like the way I spell it?
Yeah. I think they're going to the helicopter will be put on the ground and then the rover will drive away from it. So we won't be seeing that for however long until they start driving at the earliest.
John's got his mic in a different call and his speaker in a different call.
No, I'm talking. I was
responding talking to us.
Helicopter.
I tried speaking to you and you never responded, so I assumed you were talking somewhere else.
I think you're right. So there's that casing that protects it. It's on the bottom of the rover. It'll drop off, and then the rover has to move away.
Yeah, I'm more important people.
It's all nicely folded up. There's actually a hole. There's actually a hole in the bottom of the rover. So one of the legs of Ingenuity deploys, and then it has to rotate around. This leg pit will fit inside the rover, so it won't get impacted. So it's super clever. And if you haven't already, I would really recommend looking at some of the resources that NASA put up to just help people get excited about the mission. If you haven't been there already, it's so cool.
See, this is how it will.
I'll put the.
It'll be interesting because you can't really actively fly a drone, right? Because the flight is only for a few seconds and there's a delay, so it'll just be pretty much a command that is sent by the engineer.
As far as I remember, the flight is 90 seconds,
Exactly.
and it will take quite a lot of time for charging as well. So it will be an autonomous flight.
Yeah.
Yep, yep. So it's really NASA does these it puts these proof of concept elements in missions. So for example, with InSight, or the mission that was the lander, they had those CubeSats. That the CubeSats followed the InSight capsule all the way to Mars, and the mission for the CubeSats was just can we get there? What were they called? Marcos?
Yeah, Marco.
Yeah. And it's like, well, they're here. Let's put them in orbit and keep them going. But no. But you have to prioritize with funding and with personnel and with time.
Yep.
So we'd like them to do everything. It doesn't always happen.
Incidentally, you can also see that some of the tests that they were doing were done in a big vacuum chamber, the place with the black walls on it. They pumped the atmospheric conditions down to Mars, 1/100th of an atmosphere of pressure, so they could pretend, they could use the helicopter to see if it would fly under those conditions.
Yeah, no, that's really cool because it seems crazy. It's whatever 1/667 atmosphere.
Well, Ladakh is only like 70% of 70% of an atmosphere.
Well, at the highest point, it's almost 60%. Yeah, yeah.
But still a lot more.
So we actually flew a drone to shoot a short video in Ladakh, and the wind was really strong. So it's
you
hard,
never saw
hard
it
to
again.
We almost never saw it again. It almost flew into the lake.
So no, I mean, the thing is, there's Mimi Young. There's so many great YouTube videos. If you guys are interested, I would just go and stick in Ingenuity with the correct spelling and watch them. They're just great. Testing details of the rover and how much it weighs and how many solar panels are on top. And what happens? Do they have redundancy in the wings? It's a lot of cool things. But yeah, I think they're nominally not. This is like the requirements to achieve mission success would be 3 sorties at 90 seconds each, and a maximum elevation of about 330 meters.
I have one question.
Yes, Shrikant, go ahead.
Is we are taking some sample back to Earth in this mission?
Shrikant, that's a good question. So this is the first one of the early steps for the Mars sample return. So NASA has decided that this mission will, this mission will include collecting samples and sticking them in little caches. The caches look like a small tube. This is my chapstick. They're not too much bigger than this. And they're metal casings, so they're going to essentially make smaller or co-minute the samples and load up these little tubes, and then bring this tube on board, rather store them in a carousel. And so one of the next missions, just by committing to this sample return, it means the next big NASA mission to Mars will have to go back to Jezero or nearby Jezero to collect the cache of samples. But we know from how much we learned from the Apollo program on the moon that we can learn so much more about the geology and the environment of a planet by looking at samples using the probes we have in our Earth labs. So the community and NASA decided it was a good investment to commit to this Mars sample return. Oh, here's someone. Mark says, if Ingenuity works, I heard that NASA will be holding competitions to hire the best drone operators. Haha. Okay, just kidding. Why not, Mark? I mean, I swear, if I were 5 years old, that's what I want to do.
This is where it starts, right? If you can get, if we can talk about the sample return, there's the famous case where there was a high schooler from somewhere around Pasadena who went on her school trip to JPL and went there just as the Spirit and Opportunity were landing, and got so excited that she went and got her finished her high school and went through college and got her degrees, and then she was the last person to actually drive those rovers on Mars. So the thing is that if you're thinking about sample returns, maybe your 5 or 6 year old child would be one of the folks who's going to study that.
No, it's you know, it's never too late, right? But it's also never too early.
Right.
Hackathons.
Hackathons, yeah, that's another thing.
Mm-hmm.
Well, and it'll be interesting to see how our endeavors on Mars co-develop with commercial space efforts. I mean, we hear more about lunar efforts, and NASA is relying more and more on commercial rockets and
Venus.
And Venus. but I mean,
and Titan.
It's going to be so cool the next 10 years. And Titan, right? Although was Dragonfly canceled?
Was it?
I didn't hear. I thought it was not, but I don't know.
Yeah, I'm sorry. I don't want to create a false rumor, but I think that because of funding shortfalls and because of the pandemic and the redirection.
I knew it was delayed to 2028.
Okay, so I hope it wasn't canceled.
Oh my gosh.
But that was like, I heard that way back, probably like a month back or something, maybe even more, a couple of months back.
Way back a month ago.
Way more than that. Actually, it was during our course because I remember I had a slide on it and I changed the 2026 to 2028. I really hope it's not cancelled. I was really looking forward to that mission.
Oh yeah, me too. It'll be very exciting. So Anirudh has a question that actually there was a question we had earlier that we didn't address, which was, will Perseverance be able to inspect and find out why there is a seasonal fluctuation in the methane and oxygen levels in the Martian atmosphere? If so, which instruments will be used? So that's an interesting question. We've seen using the SAM, the Sample Analysis on Mars instrument on Curiosity, we've been able to look at first the composition of Martian gases in the atmosphere, and also how that varies using over the years that Curiosity has been active. And so to do this, we use something called the tunable laser spectrometer, which is an onboard instrument on Curiosity. So we don't have that same kind of analysis tool on Perseverance. So we may be able to see some signals with the spectrometer on SuperCam, but I don't think we'll be able to see it to that level of detail. I mean, I just don't know, but it's not part of the mission, I guess, objective. But that's interesting. What is the source of the methane anomalies we've seen on Mars? Are they real, or are they an artifact? And I think this is a topic still under debate.
So I just visited the Lunar and Planetary Science Conference website. There will be sessions devoted to Dragonfly. Okay. That might be good evidence that it's not canceled, but whether it's delayed or not is not clear.
I'd heard there was actually a landing site announced or chosen for it as well. So I haven't seen any cancellation.
Okay, then please ignore what I said.
No, we can't now.
Not possible now.
Yeah, I'm just looking online. It says it's been delayed, as Sid mentioned. So it was not canceled, but it's been delayed. Have readiness in 2027. So that's only 1 year. It was initial launch in 2026. Now NASA has requested Dragonfly team to pursue their alternative launch readiness date in 2027. No changes needed to the mission architecture. So you know what?
Because it's still like 7 years away, right? So you'd expect it to.
We would not be surprised if it slips.
Launches to Saturn don't happen every year, though. So that's I think it's much more difficult.
We don't. NASA doesn't use the term delayed. We just say it just slips.
Slips.
So James Webb just slipped.
It slipped quite a bit.
It sounds dangerous from an engineering standpoint, doesn't it? The mission slipped. I don't know.
I gotta bounce. Nice to see everybody. Hope to see you again sometime soon.
Absolutely, we should do this more often.
Yeah,
under equally festive conditions.
Yep.
Yeah, and by the way, Mark, that beard, my gosh.
Oh my gosh, I did not recognize him at all.
Yeah. Wow.
Gosh, you got
everybody.
It makes me COVID safe. See you soon, Rakesh.
COVID safe.
COVID safe. How do you wear them?
Okay, bye, Rakesh. But this when is the next Space Geeks meeting? I mean, online meeting. And how do you Chinta and how do you sign up to if people online would like to be notified of Space Geeks activities? How do they sign up?
So generally we are active through our Facebook page and our Instagram and Twitter page. And
Can you put those in the chat box so everyone can see?
yeah. Vaibhav, can you share it?
Yeah.
And so the next event we might plan is we are waiting for, first of all, that the COVID condition gets over and we actually get back to our night sky observations. And then if things are really well, you might even visit Lunar Crater, and that is immediate plan.
How is the night sky viewing in Mumbai with the soaring and activity? Is it better, or there's probably still a lot of light pollution?
No, so we don't observe it from exactly from Mumbai. So we go to outskirts of Mumbai, and even not so far from Mumbai, and from there we observe sky. So it's like the overnight sky observation. So generally on weekends we organize these events. So it's like we meet up on Saturday evening, and then we take participants to the location, and then we are back in the morning.
I have a few friends who do night sky photography, and they'll go off into they can find. And usually there's a circle. They go together, so it's like they go camping for days in the middle of nowhere to take the best pictures. It's cool.
Right. So we do show participants how with basics of astrophotography, but we don't go much in detail. In fact, we have a plan to have a full-fledged astrophotography workshop, like which will run for for a week or so. But then in that case, we plan to do it in like North India, like in near Himachal or Sikkim, because there you will get a really good sky, and then we can have like a week long workshop on astrophotography.
Actually, yeah.
Go ahead, Sid.
I was just saying, Chinta and I have been talking, and it'll be great to have a night sky project in Ladakh as well.
Yeah. In
That
fact,
sounds amazing.
2-3 weeks back, we tested our meteor camera, and in fact, while testing, we got a meteor captured.
Nice.
Oh, really? Wow.
Yeah.
So I just see that they will stick a route or stuck the link for the Facebook page so everyone can sign up there if they want to be notified of upcoming Space Geeks activities.
Yes.
And I also put a link to a space photography site by Mark Gee, and he lives in Wellington, or just outside of Wellington in New Zealand. And I know him a little bit. He works for Weta Digital Labs, so the people who make Avatar and Lord of the Rings. But he gives a lot of, he travels around the world now, but he gives a lot of workshops on how to take best night images. And but I think it's practice and having it's great if you did it in a group, because then you could all compare your pictures.
Right.
And the most successful operators could share their technique with everyone else. That's cool.
So we are looking forward to contribute in the Ladakh Mars station, and we'll be definitely interested to set up a meteor camera.
Yes.
So we'll soon get in touch with you, and our camera is ready, and it's just that how to go about installing the camera in Ladakh, because considering it is at very high altitude and no humidity aspect, so we will be expecting a really good even the faint meteors can be detected by this camera.
And I got some also good images during the Gemini meteor showers, which are also shared on our page, as well as we have been trying the capturing meteor using the video cameras, and there are some videos we have recently got. So
cool.
Those, yes.
Oh, I'll go look. I look forward to seeing those. I was wondering, could you could you write a proposal to get a camera that you could leave up at Ladakh, that where you could control remotely?
Yeah.
Yes.
I don't know to what agency you would write that sort of proposal, but I mean.
So I would encourage Chinta. I'll get you in touch with Margarita Safanova at Indian Institute of Astrophysics, and she has similar ambitions and energies, and she would be very happy to join forces with you guys, and she'd be able to also guide you because there is a, you already know this, there is an observatory in Ladakh, Hanle Observatory, and there is an engineering team that sits there as well. So we can always, they can always, they're already kind of in principle in support of whatever amateur astrophotography work that we are going to do or meteor tracking that we're going to do. They are happy to support us with that as well. So I'm happy to connect you with them, and they can also find a way in which we can bring some funds in to set up something that you can leave there. So it's not something that is of your personal equipment that you use for your regular sessions.
In fact,
Oh,
that when the data comes, the data should be open to students and
Yeah.
actually teach them from the video streams how you can work out different parameters related with the meteor's trajectory. Like by doing basic image processing, how you can calculate the meteor burning rate, and you can even estimate mass of the meteor, how the meteor streak intensity changes with time.
Yeah.
So things can be taught to students, and if good data comes, it becomes even publishable.
Yep.
So
Vebo, do you see there's a question for you saying, do you take any kind of summer internships for students? So I was just thinking, you put the Facebook page for Space Geeks. How about a link for Amity? And Sid and Vebo, you
I can do that. I'll do that. I'll put it there.
Just why not figure out, put as many ways on how to keep in touch.
Absolutely.
So in fact, at Space Geeks, we have been taking interns, and we in fact had a school student as first intern at Space Geeks, and he worked on the exoplanets aspects. And he actually came up with an idea that using mobile sensors, how you can actually demonstrate the light curve technique of detecting exoplanet. So he did that
with your mobile phone,
grade 12, and I think now he is pursuing his BSc astrophysics in US. And we want to really promote this. It just because of the pandemic, we couldn't continue that in the offline mode. But if somebody is interested, we can definitely work it out. And now, since we are networked with Siddharth, Dr. Jane Blank, and other experts, even we can work out a project together.
I hope so. I mean, it was certainly nice to meet you all in person, and I think it's, I don't know about you all, but it is. Zoom meetings are great, but it's so much more fun in person. I think that's great. When you're online and you're connected, as soon as you're talking, when you're back to your own closed space, it's better when you're in person. But yeah, so Sid put up a link to the Astrobiology Center of Excellence, or sorry, Amity Center of Excellence in Astrobiology, the ACOEA.com site. So I'll put that link there. The Space Geeks Facebook page. And I hope that that you guys are listed on who best to reach out to for getting involved with trying to get an internship. I think this program is great.
Awesome. All right.
I think this is it's great to have a company as we watch the official landing on the NASA website. It's really fun to have all your company and had some good questions. And
yeah.
Thank you so much.
Now we'll let you go to bed or something.
Yeah.
Dr. Jane Blank for accepting our request to join for this watch party, and I'm sure for all of us it is going to be very memorable that we are part of witnessing this historic moment of Perseverance rover landing on Martian surface. and it is going to create a lot of opportunities for scientists, engineers, and a lot of data is awaiting for us to probe the science of life on Mars. And I thank Dr. Siddharth Pandey and Dr. Vaibhav Raut to be a part of this event and representing Amity University. And I'm sure we continue to get this support from Amity and to host more such exciting events, and even like offline events in the form of workshops and maybe interactive meetings. And I thank all the participants, because without them this event wouldn't have been successful.
Yeah.
And
Yes.
and they were awake till late night, and
Yeah.
uh, their support was really, we really appreciate their support.
Did tell me there's a holiday for the
The ones in Mumbai, the ones in
only-
Maharashtra have a holiday tomorrow.
Maharashtra.
Yeah.
Maharashtra.
Yeah.
So if you live in that state, have to get to sleep in.
The others need to sleep right away for their next day.
All right. Well, that's good. And
Thanks a lot. Thanks
yeah,
a lot,
thanks.
Chinta and Vaibhav.
Thank you, everyone.
Thanks a lot
Yes,
for this
thanks.
event.
Yes.
Take care, everybody.
Okay, bye everybody.
Okay, bye-bye.
See you later.
Bye-bye.